All right, guys, we are working through our normal bell curves here, and we are going to continue with talking about Marty from Back to the Future and the DeLorean car that he has to drive to get back to the future. And what we have here in your notes is the distribution of speed follows an approximately normal distribution with a mean of 80 miles per hour and a standard deviation of 7.7. So I want you to pause the video and label the appropriate values on our normal distribution curve. So this is just like how we set up in class yesterday for the times for the stopwatch. So remember that at 0 standard deviations is your mean, and you're working away from that. So pause it, fill in your values, and then come back. So you should have had 87.7 at 1, 95.4, and 103.1 going up your bell curve, and then going down should be 72.3, 64.6, and 56.9. Now the notation we'll use when we're talking about a normal distribution is we'll put an N for normal, and then in parentheses you'll write your mean and the standard deviation that follows. Okay, so that's our notation for our bell curve. And what I also have here on the right is the empirical rule, or the percentage breakdown. So you can see within each of the standard deviations what percent of the data. So, and these all go from the middle of the mean. So 34% goes up to 1 standard deviation from the mean, 34 goes down, and so on. So take a minute and try to answer questions 2, 3, and 4 using the empirical rule and the percentage breakdowns in each section. So for the first one, greater than 87.7 miles per hour. So that's everything above 1 standard deviation. And to do that, I would be combining my 13.5%, 2.35, and the very end of the tail, the 0.15, for a total of 16%. We could have also thought about this in terms of, I know the entire bell curve is 100% of my data, and so half is obviously 50%. And so instead of adding all the percentages together, you could have done your 50% minus the 34%. That would be between 0 standard deviations and 1 standard deviation. For number 3, between 64.6, so down here at -2 standard deviations and up to +1. So we're looking for this total area of our percentages. So for this, I would have done the 13.5 plus 68% for a total of 81.5. For everything less than 64.6, so everything less than 2 standard deviations, which is just the little tiny tail of 0.15 and the small section between -2 and -3, for a total of 2.5%. So hopefully those went okay. Now, things change a little bit when we get to number 5, because we're being asked for percentage of the runs with speeds less than 68.45. And if I come up to my bell curve and mark where 68.45 is, I'm approximately here, which is not one of my regular values that I work with. So what I need to do is first I need to standardize my score, or come up with my z-score. So our first step is going to be finding for z, which is, remember, our value minus the mean all over the standard deviation. which in this case, which would be 68.45 minus my mean of 80 divided by my standard deviation of 7.7. And this gets me a z-score of negative 1.5. And what I do with that is now I'm going to go to what's called Table A, and this will be in your resources folder on Schoology. It will be the student resources packet, and this includes things that are given to you on the actual exam. So you've got formulas for mean, you've got standard deviation formulas, you've got formulas we haven't even talked about yet. And then I think page 4 here is our table A. And if you look at the top, it has this diagram of a normal curve, and the shaded region is the probability or the area. And that's what we're looking for. So to read table A, I'm going to look for my z-score. So your whole number and the first decimal will be going down on the left. So I'm looking for negative 1.5. So I come to negative 1.5, and then your second decimal goes across the top, and my second decimal here is 0. So my value is 0.0668. Whoops. So back on our notes, from table A, I know that the area at my z-score value of negative 1.5 is equal to 0.0668. So the answer to my question is 6.68%. And we're going to try another one. Percentage of the runs will give the DeLorean a speed greater than 85 miles per hour. So first thing I'm going to do is I'm going to sketch my bell curve. And remember, my mean is in the middle. And then I can put some of my standard deviations on here just so I have reference points to look at. And this is my unstandardized bell curve. So N would be mean of 80, standard deviation of 7.7. And I am looking for 85 miles per hour. So that's going to fall out here-ish. And we want everything that is greater than 85 miles per hour. So I'm looking for the area under my curve to the right of 85 miles per hour. Now I could also draw my bell curve as standardized scores, which would make the mean 0 and all my values going across, which are my z-scores, okay, or the number of standard deviations away from something you are. The curve looks the same and the position of your number is the same, but now our notation would be N, a mean of 0, and a standard deviation of 1. So to solve for this, we are once again, first thing going to do is find our z-score. And you should always write your formula. So z equals value minus mean over our standard deviation. Then you can plug in your values. So here it's 85 minus our mean. So we get a z-score of 0.65. And once you have your z-score, we can go to table A again. And we're looking for the area at z equals 0.65. I'm going to pull my table up again. And I'm looking for, clear all of my other highlights here. So I'm looking for positive 0.65. So first you want to get over to the positive side. And 0.6 is across this row here. And then I'm going to my second decimal of 0.5, which would be a total of 0.7422. Back to my notes. So my area is 0.7422. Now, the important thing about table A is this value that you get from table A is always the area to the left. So it's everything that's less than. This question is asking for speeds greater than 85, which means I need to find the area to the right. So we're doing 1 minus 0.7422 for an answer of about 25.78%. Okay. So it's really important to know that table A will always, always, always be the area to the left. And if you need something to the right, that means you need to find the difference. Or you'll get a problem like number 7 here, where we're looking for the value between two numbers. So again, I can sketch my bell curve just so I know what I'm looking at. And it's good to draw your bell curve standardized and unstandardized because you'll be able to see kind of z-scores you should be expecting. So I know 2 standard deviations above it is 95.4, which means this z-score would be just below it. And going in the other direction, I know 1 standard deviation below is at 72.3, so I am also to the left of that. So I'm looking for this middle section of my curve. And we're going to follow the same process, but we're going to have to find the difference between the two. So first, again, solve for your z-scores, and I would say you should pause this and solve for your z-scores, and then come back and check them. So your z-score for 95 should be 1.95. Your z-score for 70 should be negative 1.30. Now pause it again and come up with your areas for these two z-scores from table A. Now from table A, at z equals 1.95, we have an area of 0.9744. Now what that means, and I'm going to highlight it here on my bell curve, everything to the left of the 95 miles per hour covers about 97% of the data. My z-score for 70, which had a z-score of negative 1.3, was 0.0968. And again, I'm going to highlight this on my diagram. So that includes everything to the left of this line, which means to solve for just that green section that's included in between both of them, I'm going to take the difference. I'm going to subtract these, which means I get 0.8776, or approximately 87.76% will fall in between 70 miles per hour and 90 miles per hour. In my last example here, I'm being given the percentage, and we have to solve for the speed. So again, sketch yourself a diagram, label it with your mean and standard deviations. And I'm only going to do the right side because I'm talking about the top 15% of my values. Okay, so the question is asking at what speed do we need to be at to achieve the top 15%? So I'm just going to highlight kind of where I think I need to be. and I can still put my notation, so 80 and 7.7. And what I'm looking for is my unknown value, but I know the area is equal to 0.15. So with an unknown value, you take the area you have and find the area in the center of table A. So I'll show you what I mean by that. On table A, everything that's in the middle in these big rows and columns, those are all your area values. So what you need to do, and this will come with practice also, is look at the middle of table A here for the value that's closest to 0.15. And we are going to be looking at we are looking for, since we're looking for everything to the right, okay, we are looking for 0.85 because this will tell us the area to the left. So we are going to end up with 0.04, I think is going to be our best bet here, which means we come back here, we say z equals 1.04. And then our second step is to work backwards and find the value. And when I say work backwards and find the value, we're using the formula of z equals the value minus the mean over standard deviation, and you're plugging in what you have. So this time we have the answer, z is equal to 1.04. We're looking for the value, and that's what we're solving. So again, pause it, see if you get it. And you should get about 88.01 equals x. In terms of this question though, what speed do you need to go? It's 88 miles per hour. So watch your units on this, whether you're talking about the value or the percentage. The notes here I will post with the big ideas. It'll have just the formula and a basic idea of what we did, and do some practice and try the check your understanding.